Okay, my friends. So I'm going to use another data set to illustrate an example of something you're about to do for your data set. I'm using the random.org website to generate some rolled dice. So I'm going to roll. Just this every time I hit roll again, it's rolling 50 more dice that are six-sided. 1, 2, 3, 4, 5, and 6. And I'm just going to hit roll a couple more times, and then I'm going to stop. Okay. Now let's suppose I'm interested in one of the numbers I get. So if you think about a six-sided die, you should get roughly equal numbers of ones, twos, threes, fours, fives, and sixes. Roughly, if you roll lots and lots of dice, that is infinitely many dice. I'm just going to pick a number. I'm going to pick 3. How many threes did I get? All right, 1, 2, 3, 4, 5, 6. Looks like I got 7 threes out of 50 rolls. So 7 threes out of 50 rolls would be 14%. Now, you might say to yourself, well, you got 14%, Sean, but you just got done saying that it should be closer to 17%. Well, that's true, but remember, the 17% is assuming the entire population has been measured. This is just a sample. Is 14 different than 17? Well, in order to calculate that, we need a margin of error. And that's what we're going to learn how to do here with the website that I have linked on your exam, which takes you here. Okay. Now, there's a couple parts to this that we are going to take for granted now, and then we're going to learn about more in detail. You're going to fill in this top part. As far as the confidence level, you're going to leave it at 95%, and we're going to talk about why as we go through the back part of this course. The sample size, for me, I rolled 50 dice, so I'm going to change that to 50. You'll have to change that number to match whatever you did for the R2-D2 problem earlier. My sample proportion, now remember, I'm interested in the percentage of threes that I got. I got 14% threes. And a population size, I've never liked when they ask you for population sizes, so I treat it as optional. I want to hit calculate. The margin of error around my statistic is plus or minus almost 10%. You can see it right there. If you're interested in the calculation, and like I said, we'll get into this more later in the course, that's the formula for it right there. It's a little hellacious right now, but like I said, later in the course, we can chat more about where some of these numbers come from and why they are there. But the margin of error is almost 10%, which means I shouldn't say there's a 14% chance that I roll a 3. I should say there's between a 4 and 24% chance that I roll a 3. All right, you got the tools now. Go apply it to the R2-D2 data.